Hi guys, welcome back to Octet Sci Academy. Today we're going to be learning about an interesting concept. We're going to be learning about separation techniques. That is, what are the ways in which scientists or everyday people use to separate mixtures. Don't forget to like, follow, and share. Please subscribe and share with your friends and colleagues. Separation techniques are ways by which we separate mixtures. We already learned about mixtures, compounds, and elements in the previous videos. Mixtures are formed when materials, substances such as compounds, atoms, or elements are combined with another compound, atom, or element without the formation of a chemical bond between them. So those components are joined together physically. That way, it is easy to separate the components of the mixtures using physical means because no chemical bond exists between the components. So it is easy to use physical means to obtain each component of the mixture. Why do we need to engage in separating mixtures or use separation techniques? At times, we need it for purification and to obtain useful substances. So you have a contaminant in your material. If it is a mixture that is not combined together with your material, then you can use certain separation techniques depending on the properties of the material to separate them. Now let's see some examples of separation techniques. Don't forget to subscribe, like, follow, and share. The first separation technique we're going to be looking at is sieving. Sieving is a technique that can be used to separate a mixture that is comprised of two solids of different sizes. So for sieving to work in separating a mixture, the mixture has to be made up of solids and the solids will have to be of different sizes. As the name implies, with sieving, we're going to be using a sieve. So for sieving, we're going to be needing a sieve. And for this experiment, we're going to be using two solids of different sizes. So we're going to be using table salt and some pebbles of stone. So we'll make our mixture of salt and stone in this beaker. So here I have a mixture of salt and stone. So my mixture is made up of two solids that are of different sizes. As you can see visually, inspect it, the solids are of different sizes. Now let's try to separate this mixture. So we have another beaker that we're going to be receiving the smaller size particles. So you get a sieve and there are different mesh sizes. So when you have a sieve of different mesh sizes, you pour in your mixture, and then depending on your mesh size, you give it a toss like this. You see that solid particles that are smaller in size will go through the mesh, while the solid particles that are of larger size will stay on the sieve. That way, we have successfully separated this mixture of sand and salt. Another technique we're going to be talking about today is filtration. Filtration is a separation technique that is used to separate mixtures comprised of a solid and a liquid. However, the solid won't go into solution in that particular liquid. So if you have a mixture that is made up of a solid that does not dissolve in that particular liquid, then you can use filtration. What are the things you need to do filtration? You're going to need a filter paper like this one. You're going to need a funnel, and then you're going to need some flask to receive your filtrate. Now let's do a filtration experiment. For our filtration experiment, we're going to be using a mixture of sand and water. So I'm going to add some sand into the beaker and then add some water to make a water sand solution. There we go. Sand does not dissolve in water, so this mixture is perfect for filtration. As you can see, sand does not dissolve in water. So if we want to separate this mixture, we can filter it to get rid of the sand and remove it from the water. So we have our sand and water mixture sitting on one side. Now let's set up the other part of the experiment. So we're going to need a flask, a receiving flask. We're going to need a funnel. So I'm going to put it like this. And then the filter paper, this is how you fold your filter paper. You fold in half and then fold the half into quarters like that. And then, so you have the sharp edge that is going to go into the funnel. Then you have 1, 2, 3. So open it up here and then put it in the funnel like that. So now our solution is ready to be filtered. So we're going to pour in our mixture and we're going to see the water is able to go through the filter paper while the filter paper holds the sand. So we just pour. Make sure to not overfill the filter paper because you don't want anything to escape out of the filter paper. And you see the water begins to travel into the receiving flask and the sand will be on top of the filter paper. So we're going to continue to do this until we're able to filter all of our sand water solution. You can see that is dripping down bit by bit. So we still have a little bit of water left and it's still dripping into the flask. That is fine. You can see we have the last bit of water dripping into the flask now, and you can see the sand is sitting atop the filter paper. That is exactly what we want. At times, you can be asked in certificate exam to name certain components of a filtration experiment. The liquid that is received in the flask is called filtrate. So this is in a filtration experiment, the liquid that is received is called the filtrate, while the solid that is left on the filter paper is referred to as residue. So here in my sand water mixture, the sand is the residue and the water that is collected in the flask after filtration is called the filtrate. Can you see now that we've been able to separate the sand from the water solution? Evaporation going 3, 2, 1, 0. Another technique that we're going to be looking at today is evaporation. Unlike filtration, where the solid has to be insoluble in the liquid to use filtration. In evaporation, evaporation allows us to separate mixtures in which the solid dissolves in the liquid in the mixture. So an example of that is salt and water. So I have some salt in my beaker already. I'm just going to add some water to it and make sure that goes completely into solution. Evaporation uses heat. So I'm going to go heat this up now, and you know what's going to happen? The water will boil, it's going to evaporate off, and I'm going to be left with my salt. So let me make sure the salt actually goes into solution. So when you have salt readily dissolves, table salt readily dissolves in water, and then you have a solution where the solid has gone completely into solution. So if I heat this up until the point of evaporating the water off, I'm going to have my salt back. I'll be back to show you the salt. I'm doing this at home, so I'm just heating up on the stove, and look at that. Look at the salt particles. Now I've heated up the salt water solution, and look at the salt particles that are left after evaporating of the water. So when you have a solid that dissolves in a particular liquid and you have a mixture comprising of just those two, the solid and the liquid, to form a solution, then you can use evaporation. So I've done that with salt and water, table salt and water, made a salt water solution where salt completely dissolves in water, and then I heated this up on the stove at home to evaporate off the water, and look at my salt that I've been able to recover. Another separation technique is sublimation. Sublimation is the process where a material changes directly from the solid state into the gaseous phase without going through the liquid phase at all. So a material sublimes when it goes directly from solid to gaseous phase without going through the liquid phase at all. Iodine and dry ice are examples of solids that undergo sublimation. Let us see how this process works. So in this beaker, we have iodine crystals, and it is heated slightly, and you can see the purple fumes that is being given off. That is iodine being sublimed. It's changing directly from solid to gas into the gaseous state. Can you see? And if you put a cold flask on top of the beaker in which the vapor is coming from, the solid is going to condense around that round bottom flask if it is cold. So I've put some ice in that flask to make sure it is cold, and then look at the beautiful crystals that we're able to get from that. So if we have a mixture of, say, sand and iodine, we know that iodine can sublime. Sand does not undergo sublimation. We can separate that mixture by subjecting the mixture to sublimation, where we're able to sublime off the iodine, and then we have the sand in the beaker. Another technique we're going to be looking at today is magnetization. As the name implies, this involves the use of a magnet, and you can use magnetization to separate a mixture when you at least one component of the mixture has magnetic properties. That is, one component has to be magnetic in nature. For example, iron filings, which is iron is a metal, so it's going to be magnetic. Filings from iron and some sand or pebbles. Now I have a mixture of sand and iron filings. How do I separate that? I can use a magnet, because the magnet is going to attract the iron filings. The iron filings are going to be attracted to the magnet. Can you see that? Can you see the iron filings flying up to the magnet? Now I have separated that mixture, because my iron filings are going to be attracted to the magnet, leaving the stone behind, because the stone is not magnetic. So you can see the iron filings flying to meet the magnet, while the pebbles are left on the glass. And voila, we've separated our mixture. So magnetization is a separation method that you can use when at least one of the components of the solid mixture is magnetic in nature. Another separating technique that we're going to be looking at is the use of separating funnel. As the name implies, it is a funnel that is used for separation. This is what it looks like. And this technique works well when you have two liquids that do not mix together. That is the condition for which you will be able to use a separating funnel. If the liquids mix together, you can't use separating funnel. So when you have two immiscible liquids, separating funnel is such an efficient way to actually separate such mixture. you'll be shocked to know that a lot of organic chemists, people who make medications, agrochemicals, and a lot of other things, synthetic chemists of all types and forms, use this technique a lot in their day-to-day lab activities. I personally use this technique for all of my reactions that I set up. So again, you need a mixture that is made up of liquid that do not mix together. So let's use a separating funnel to separate a mixture of cooking oil. So I have some cooking oil in my beaker already, and then I'm going to add some water. Water does not mix with oil. So how do we separate this? We can use a separating funnel. Even when I try to stir the two together, you can see you still have those layers intact. So what you do, how do you use a separating funnel to separate your mixture? You open your separating funnel and you clamp it like I've done. Always use a funnel. So I'm going to use a funnel and make sure the tap is closed, because if the tap is not closed, you're just going to have your mixture splash everywhere. Now, just to make sure that you're not losing any of your mixture, it is prudent to always leave a flask at the collecting side of the funnel, even though you have closed the tap. This is to make sure that you do not mistakenly lose any of your mixture. So then I'm going to pour in the water and oil mixture into the separating funnel. I'm just going to let that settle in a bit for the layers to be actually very distinct. Separation, this separating technique, separating funnel, uses the difference in densities of this liquid. So because water is of higher density compared to oil, so that's why water is at the bottom and the oil is at the top. Depending on the density of the liquid you're working with, that is what determines which one will be on top and which one will be at the bottom. So because we have our mixture is made up of two liquids, water and oil, I've got two flasks that I'm going to use to collect the various components of the mixture. Now look at that. We have the two distinct layers of this mixture formed. We have water at the bottom and oil at the top. Now it's time to separate our mixture. Like I said, I need two flasks to collect each of the components. So this is going to be flask one, and I'm going to be collecting water first. You can keep this on if you want to control the flow. You can keep the lid on if you want to control the flow. If you are more confident, you can leave it on so that it flows faster. So I'm going to open, you're just going to gently open the tap, and then you collect each fraction like that. So I'm collecting the water now, and then we just continue to go. I've collected the water from this mix. So just collected the water. So look at that. We've collected the water from this oil and water. We've collected the water from this oil and water mix. Now it's time to go for the oil. So I have another empty beaker that I'm now going to use to collect the oil fraction of this mixture. And that is taking a sweet, sweet time to walk through. So you can see the oil is coming through. Yeah. And then that is going to just Just continue to pour in. Look at that. And look at that. We've been able to separate our oil from the water. So flask 1 is the water. The second flask contains the oil using a separating funnel.